So it's time to review our quiz 7 together. This section really focuses on our chapter 9 and the beginning of our chapter 11 material. So solving trigonometric equations for values of theta, which pops up in our chapter 9, and then chapter 11 begins with finding your distance formula. So distance between 2 points, and your midpoint formula, which is if you have two coordinate points on a plane, finding that middle point wedged between point A, for instance, and point B. Let's jump into it and start with our question 1. So we're asked to solve each trig equation, we're only given one here, for all values of theta along this interval 0 to 2 pi. Anytime we're given an interval, we're in good shape because that means we are going to have definite answers. It's not going to be a general formula where we're representing all the coterminal angles as well. So what do we do first? We want to get that cosine theta all alone. So how do we do that? Let's go ahead and divide both sides by 2 so that we have cosine theta is equal to negative square root of 2 over 2, which you want to think into your head, 45 degrees, or some form of 45, aka pi over 4. But off to the side here, let's just look at this visually so that we know, okay, we're dealing with a negative square root of 2 over 2. So what's happening to our trig functions if we are in quadrant 1, 2 versus 3 or 4? Quadrant 1, once again, our whole acronym, all students take calculus, helps us with this. All of our trig-related functions are positive here, whereas second, only sine-related, cosine, only, or cosine. Third quadrant, only tangent-related functions are positive, and then finally, fourth quadrant, only cosine-related functions are positive. But here, in our result, we have a negative result, and we're dealing with our trig function cosine. So we're actually looking at solutions that are both in quadrant 2 as well as quadrant 3, since we want cosine to be negative. So in the green highlighted is where all of our solutions lie. And again, that 45 degrees, that pi over 4 for our reference angle, is how we're going to determine what our two solutions are going to be, because there's only two, since we're looking at the interval from 0 to pi, and then since we're only looking at solutions that pop up in our second and our third quadrants. So if pi over 4 here is our reference angle, then 3 pi over 4 is going to be where that first terminal side hits, which is 135 degrees. And then 5 pi over 4 is going to be where our second terminal side hits, also known as 180 plus 45, 225 degrees. So what are our two solutions for theta? 3 pi over 4, and we're going to keep it in radians for our final answer because notice how the bounds in the question, 0 to 2 pi, is in radians. So our solution should also be in radians. And I guess we don't even need the equals part since that's already given to us. And that's it. That completes our question 1. Oh, there is a part B. So, and then do we have a part C? Nope. So it's 2 parts to this question 1. So we have another trig equation that we want to solve. And again, the bounds are going to be from 0 to 2 pi. In this particular example, notice how we have a sine squared and then a sine theta. So it would be in our best interest to manipulate this and put it into quadratic form. For instance, let's use some substitution. Why don't we let x be equal to sine theta? And when we do that, we're going to replace every sine theta that we see with x. And because this part in our first term has sine squared theta, we can replace that with an x squared. So we end up with 2x squared minus x, also known as just 1x, minus 1 is equal to 0. Much easier to look at. In fact, can we factor this? Let's go ahead and use our AC method since our A value is greater than 1. We have 2 times -1, which gives you -2. What are factor pairs of -2 that add to -1? That's just -2 and +1. And so we are going to now keep that first and that last term exactly the same. But that middle term, we are going to be breaking that up into what we have circled here in that dark yellow. So a minus 2x plus 1. We're just manipulating. Math involves a lot of manipulation, right? -1x is the same as -2x plus 1. Hence our manipulation. And so from here, we're going to jump into some factor by grouping. The first two terms, we can pull out a greatest common factor of 2x, and then we're left with x minus 1. And then the last two terms, and notice how I forgot a little x here, but we can factor out, let's just factor out a plus 1. And then we're left with our x minus 1. And if we completed factor by grouping correctly, inside the parentheses, we should have the same binomial. And we do. So we did it correctly. We're going to now factor out that yellow binomial. And when we do, inside our other binomial or parentheses is going to be our binomial 2x plus 1. It is factored. Let us now find our values for x before we substitute back in our sine theta. So if we set x minus 1 equal to 0, we just simply get x equals 1. And then if we set 2x plus 1 equal to 0, we end up getting x is equal to -1/2 by just straightforward inverse operations. Now we can substitute back in for our x. Our x is the same, or for our sine theta, our x is the same as sine theta. And so we have sine theta is equal to 1, and then we have sine theta is equal to 1/2. Essentially, -1/2. We just want to find all of our potential solutions. I'm going to, maybe I'll shrink this a little bit so we have just a little bit more space. Okay, much better. So I'm going to go ahead and draw out our little unit circle off to the side here. And sine of theta is equal to 1. The only solution that makes this possible along those bounds 0 to 2 pi is our pi over 2. So theta here is equal to pi over 2, aka 90 degrees. And now for sine of theta is equal to -1, those first two quadrants, our sign is positive. So we're really going to hone in on those bottom two quadrants, 3 and 4. And to get 1/2, you can take the sine of pi over 3. So we want to look at, okay, what is our reflection or what are our reference angles for quadrants 3 and 4 with pi over 3? Okay. We have this terminal side. Think about cutting that quadrant into 3 equal parts. And then we have this terminal side. It's not drawn to scale. Which means we have, okay, pi plus pi over 3 is 4 pi over 3. And wait, I keep saying pi over 3, thinking that that is 30. Pi over 3 is 60 degrees. We're looking at pi over 6. So I drew it properly, but I was just saying the wrong angle. We have pi, also known as 6 pi over 6 plus a pi over 6. So we get 7 pi over 6 here. And then we have 12 pi over 6 is 1 full rotation, also known as 2 pi. So 12 pi over 6 minus a pi over 6 gives you 11 pi over 6. And those are our two solutions in order to get sine of theta is equal to 1/2. So here we have theta is equal to 7 pi over 6 and 11 pi over 6. This is why the unit circle really helps, and having a very good foundation of fractions, as well as being able to very easily convert back and forth from radians to degrees or degrees to radians. So we end up getting 3 solutions. We have our pi over 2, we have our 7 pi over 6, and we have 11 pi over 6. Okay, so we completed our first question. Now let's jump into our second question on the next page, where we're asked to show that 1 plus tan squared theta is equal to our secant squared theta. And I gave you a little hint here. Anytime the question asks you to show something, you technically are proving that this identity is to be true for all values of theta. And so we want to keep one side constant and then manipulate the other side. My hint for you here is to really keep your right-hand side constant. So don't mess with that secant squared theta, but really try and tinker around with the 1 plus tan squared theta in order to get it to equal to our secant squared theta. All right, let's do it. So I'm going to actually write it down again over here. We have 1 plus tan squared theta is equal to secant squared theta. And because we are not messing with that right-hand side, I am actually going to bring that guy down all the way to the bottom. Okay. Now, that left-hand side we are going to mess with. 1 plus tan squared theta. Well, we know secant squared is 1 over cosine squared. So maybe it's in our best interest to manipulate that 1 to have a denominator of cosine squared. Why don't we multiply 1 by cosine squared theta over cosine squared theta? And then with tan squared theta, we know tangent in terms of sine and cosine is just sine over cosine. So why don't we change tan squared theta into sine squared theta over cosine squared theta? And so when we do that, on our next row, we'll end up with cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. Now that the denominators are exactly the same, we can put this all into one fraction. Cosine squared theta plus sine squared theta all over cosine squared theta. Ooh, that numerator is a Pythagorean identity. So maybe off to the side here. Actually, I'll just copy and paste it. Cosine squared theta plus sine squared theta is just what? That's just equal to 1. So why don't we replace it with 1? We end up with 1 over cosine squared theta. Isn't that our definition of secant squared theta? And didn't we just now prove the problem to be true? Secant squared theta equals secant squared theta. So therefore, 1 plus tan squared theta must equal secant squared theta. And we've completed this proof. We are done. Question 3 and 4 are a little on the easier end. We're stepping away from trigonometry now, and we're back to just using straightforward numbers. Question 3 is just utilizing our distance formula to find the distance between 2 points. So in order to get full credit for this problem, you need to write the general formula for distance, which is the square root of, in parentheses, x2 minus x1 squared plus parentheses y2 minus y1 squared. And then based off of the 2 points that they give us, I'll label these for you. This is our first x coordinate point, our first y, our second x, our second y. And now let's just substitute in order to calculate our distance. So we have our distance is equal to the square root of -4 minus 3 in parentheses squared plus 5 minus -2 in parentheses squared. 2 negatives next to each other give you a positive. -4 minus 3 gives you a -7 in parentheses squared. 5 plus 2 gives you a +7 in parentheses squared. 7 squared is 49, -7 squared is also 49. So we get our distance is equal to the square root of 49 plus 49, which is the square root of 98, but we can break this up into just the square root of 49 times the square root of 2 to put it into simplified radical form. And the square root of 49 is just 7. So distance is equal to 7. Square root of 2 cannot be simplified further. So 7 times the square root of 2. And that's it. We're done. Finally, we're on our question 4, which is asking us to find the midpoint of this segment, and they give us the coordinate points. Again, in order to get full credit for this question, we need to write the general midpoint formula, which is this side notation of m in parentheses x comma y. You don't have to use that. I just personally like to use it. I have that capital M to be like the midpoint, and then I have it, oh, it's in our XY coordinate format. But this right-hand side, you do need it like this. We're taking the average of our two x values, x1 plus x2 over 2, That's going to become our new x coordinate point. And then we're going to take the average of our two y values and divide it by 2. That's going to be our new y coordinate point in order to get that middle point wedged between, in this case, 0, 8, and 6, comma 16. And I actually missing a little parentheses here. I gotta fix that on my LaTeX document. Okay. So now let's label our first x and first y coordinate, and then let's label our second x and second y coordinate. And now from here, we're going to just plug in accordingly. So we get 0 plus 6 divided by 2, comma 8 plus 16 divided by 2. Six divided by 2 is just 3. And 8 plus 16 is 24, and half of 24 gives you 12. So our midpoint is just 3, comma 12. And that completes question 4. And it also completes our quiz 7. So I hope this all made sense. If it didn't, please send me a comments down below and I'll try and make it a bit more straightforward for you. But I will see you guys all in the next video. Take care. Bye.